Hi guys, today Astra is making another attempt to launch vehicle 0006. It aborted its attempt at T-0 yesterday, which it lit some of the engines at least, and then it aborted. So we're around 12 minutes away from the expected hold. They will hold at 20 minutes, maybe for around 10 to 15 minutes. And then if everything looks good, they will resume the countdown. Well, yeah. Okay, so, yeah, you can see the vehicle is on the right view. This video is from NASA Spaceflight on YouTube. The right camera view is the video of the rocket. It's currently on the launch pad fueling up. The left is mission control, and yeah, they're launching from Alaska. Yeah, so this is, I think, the third or fourth mission of Astra, and they haven't succeeded to get to orbit yet, so hopefully this one gets to orbit. You can see there's frost around the rocket. That's normal because the propellant is really cold, so they cool it down to the negatives, so for liquid oxygen, and I think it's RP1 or highly refined kerosene. And yeah, once they mix into the engine, there's 5 E1 engines on the first stage. Once they go in the combustion chamber, they will ignite, which will then create pressure, which will then push out the nozzle. And I live in Alaska. Cool. Where in Alaska? I think I know who you are. Okay. And I don't live in Alaska. Okay. Well, yeah, we are 10 seconds away from 30 seconds to launch. Let me get my countdown up. Oh, no, it's not liftoff yet. It is not liftoff yet. It's not 8 minutes either. Okay. So 29. No. 1 second. This isn't working. Okay. Yes. Okay, yeah, I thought I knew who you were. Yeah. Uh-oh. They're holding at my 30 minutes. Let me get the sound on screen.
The hold has been called at T-minus 30 minutes and counting. We will stand by for more information and provide it when we have it. Again, there's a fair bit of time in today's launch windows, so we'll stand by and hope for an attempt later this window.
Yep, that's right. We just got the word that the hold was due to propellant load. So as you can see, we are filling up our tanks, and we are holding to catch up to the point we are in our countdown.
That's not the best news, but their launch windows are pretty long. They're like 5 hours. They were aiming for the beginning of the launch window. They pushed back 45 minutes. So they still have maybe 4 hours left in the launch window. So it's not really a big deal, except I don't really want to sit here streaming for 5 hours. So I hope they launch fairly soon. Yeah. It was due to propellant loading. That's not a usual reason of a hold, but maybe there's something new. Yeah, so oopsies. Yeah, so wait, let me get this on screen. Okay, no, not files. I need to go here, and I can go. Oh, it's windy.
All good so far.
This just said all good so far. Please. Please don't hold for that long. Well, so Right now they're holding. So
Also looking good.
it's looking good. Okay, so while we're in the hold, I'll go over the parts of the rocket. So, like, the countdown. So that's stage 1. The steel, it's frosting up right now because it's using really cooled down propellants. It uses the cooled down propellants to fit more propellant into the stage, so it works. Stage 2 is up here. It's that small little sliver up by the top in between that curved section. That's the inner stage. And then up at the top, 1 second. So this is, no. So then up at the top, there's the fairing, which houses the payload. This mission does not have a payload. It's a test payload. But it's a test payload.
So while we are waiting for this hold to continue, while they're waiting for propellant load to catch up on the vehicle, we're going to take a look at an interview from last week where I sat down with Astra's founder and CEO Chris Kemp to learn a little bit more about Astra's mission and today's launch. So let's take a look at that. Hi everybody, I'm Thomas Burkhardt with NASA Spaceflight here at Astra's headquarters, and I'm here talking to CEO Chris Kemp. Chris, thank you so much for joining us today.
Yeah, thanks for having us.
Thank you for coming on to NASA Spaceflight Live. That was an absolute pleasure. Some stuff has happened since, and we're getting ready for the launch of Rocket 3.3. What are your expectations for this upcoming launch?
Well, we hope to learn a lot. This will be a test flight of our improved Rocket 3. We'll be taking a test payload from the Space Force, and hopefully we'll have a full flight, so we'll be able to collect a full set of data for them.
And how confident are you in the success of Rocket 3.3?
Well, I think we'll learn a lot, and I certainly hope we get a full flight in. A lot of changes.
The rocket isn't cracking. It looks like that the ice is cracking. It gets covered in ice because the propellant is so cold. It freezes a layer of ice on the outside, so the ice is probably cracked. I hope the rocket isn't cracked.
Well, I think the ability to quickly iterate. We're seeing both Astra and other companies quickly make another version, learn as much as they can, and then iterate. And it's really particularly easy to do with such a small launch vehicle.
So you mentioned launch sites. What kind of places are acceptable for Astra's rockets to launch? Are you limited to the places we traditionally think of, normal launch ranges, or is there infrastructure or regulatory infrastructure in place to launch from pretty much anywhere?
Well, we can basically launch anywhere we have a license, which means we just need to find a place where we're far enough away from population centers to not bother people. And we're investigating over a dozen different locations, both domestically and abroad. Our system could be completely shipped and unpacked, and we can launch a rocket within a few days. So you can kind of see how that enables us to be very flexible. And we're going to continue to be able to develop and iterate on the entire launch system, including the spaceport, at that same rate.
So just on Thursday, I believe Astra received their authorization to operate out of Kodiak, Alaska through 2026. Can you talk a little bit about that?
That's right. We received a launch operator's license from the FAA, and that allows us to launch this version of the vehicle through 2026. It means we don't have to go through a licensing process for every single launch, but as long as we're launching out of the trajectories with the current spaceport, current rocket.
What kind of forward work is needed to start launching these rockets from more non-traditional locations, things that are not already established spaceports?
Really, from our perspective, it's just a licensing issue. So we just need a fence and a concrete pad, and we bring our infrastructure in and we launch. So very little actual
Yes, you're on the screen.
Site. A lot of work needs to go in to make sure that we're not going to interfere with the community and we're not going to cause any disruption. So we try to find places that are away from cities and population centers, typically in coastal areas.
So on NASA Spaceflight Live, you mentioned a point-to-point cargo delivery system as part of the future of Astra. But I believe Astra is looking externally for the re-entry
you are on the
part of that.
screen.
Can you talk a little bit about that decision?
Well, I think that Astra's focus right now is in mass producing and scaling launch operations. That focus means that we're not off building larger rockets. We're not going to try to put people on our rockets. We're not going to try to work on re-entry systems. And so it's a natural area where we can get something to space. We're going to partner to try to figure out how we get it back to the Earth safely.
You know, some other companies have made that same promise of saying, listen, we're in the small sat launch business, we're never going to go to bigger rockets. Some other companies have ended up changing their mind. How set are you on that? Is that something you're completely off the table, or open to potentially, if the market calls for it, Astra serving into that market as well?
Well, we've already sold over 50 launches, and we're very focused on what our customers ask us for. And right now, there is an overwhelming demand for point-to-point launch services. And what that means for us is we can't scale fast enough, and we can't focus more attention on continuing to drive the cost down and the scale up of the launch services that we provide today.
What do you believe is the sweet spot capability for a small sat launch vehicle as far as size is concerned?
Well, for Astra, it was the smallest rocket that would meet the needs of today's market today. And that's the 50 kilogram class Rocket 3 series. As we start to see more large mega constellations come online, that sweet spot moves to around 150 to 200 kilograms. Where we ultimately seeing it settle out from an economic perspective is a small rocket that can deliver approximately 500 kilograms to a mid-inclination orbit.
Do you think that you'll fly a lot of missions that are basically a 3-stage?
Okay, so do you think they'll make it this time? I hope they make it. I think they're gonna make it because the rocket looks a lot different. So, yeah, they probably changed a lot of things to, like, upgrade the engines, make sure the engines work well, do enough of that stuff, have a good TWR or thrust to weight ratio, all that stuff. So, yeah, I'm pretty sure they'll make it this time.
That are also in the small sat market, which is growing seemingly by the day.
Right, well, what we're trying to do is focus on flight rate above all else. So if we can fly, for example, next week, we'll take what we learn. So that next rocket will benefit from whatever we learn.
On launch day for this upcoming rocket, how is that going to look different from the previous launch as far as personnel involved, the countdown process as far as automation is concerned?
We're really very similar to the previous launch. We have about a half a dozen people up in Alaska. We have about a half a dozen people in a launch control room here, and we're going to be running the launch using a lot of the same software and systems that we used in December.
So what is the objective of this upcoming launch with regards to Astra serving the Space Force in the future?
Well, this will be the first launch of an orbital launch system. So it'll be a test launch being performed for the Space Test Program within the Space Force. What we'll be doing is we'll be launching to a very specific orbit and inclination. We'll be watching that closely. We have a test payload that's been instrumented. So we're going to be looking at the vibrational environments, the acoustic environments, the thermal environments, so that we can give all that data to the Space Force. So this payload will not be deployed from the spacecraft, but we're going to measure our ability to get it exactly where it needs to go.
And it was great to sit down with Chris Kemp earlier last week prior to today's launch attempt and the launch attempt yesterday. Just a pleasure to sit down and talk with him. If you are just joining us, today's launch attempt is currently in a hold. You can see we're at T-minus 30 minutes and holding, as teams are just working to catch up on their propellant loading operations before continuing into the really business end of the countdown. In the meantime, Caroline, if it's okay with you, let's dive into some more questions.
Keep them coming.
All right. So a question in chat asking about what do you use to light those Delphin engines on the first stage? Talk a little bit about that.
Sure. So again, our first stage is powered by 5 Delphin engines that are developed and built and tested here in Alameda. Each engine produces 6,500 pounds of thrust at sea level and is powered by liquid oxygen and kerosene. And we actually have a ground-based ignition system, which is one of the unique features of our vehicle. So in order to make the rocket as simple as possible, we try and put more of the more parts into the ground that doesn't fly, so they can be heavy, and so we keep the engines as simple as we can, so we use a ground-based ignition system.
So if I understand that correctly, it's about taking as much mass as possible for all the systems needed to begin a rocket launch and putting them as many of them on the ground as possible so that once you lift off, you're not carrying all of that mass with you.
That's right. We can better use that mass to increase our payload capability.
And on the other side, you also reduce the complexity of the part that is flying, right?
Exactly. It's a win-win.
Absolutely, and as we've mentioned many times, simple scales, right? Keeping going with the questions here. We do have a question about what propellants does this rocket use to feed those engines?
Yes, so both the first stage and the upper stage engines are powered by liquid oxygen and kerosene.
Gotcha. And when we're looking at a screen there, we're seeing some gaseous oxygen venting from those tanks, and the frosty part of the rocket is that super cold liquid oxygen tank above the ambient temperature kerosene tank. So that's what you're seeing on your screen. And again, we'll see that continue to get more solid frost on that upper part as the propellant loading operations catch up, and we can get towards releasing this hold. And we talked a little bit about this yesterday, but that ice that's kind of forming the frost on the outside of the rocket, that's a negligible amount of mass that shouldn't affect the flight of the rocket.
Yes, that's right. And you'll potentially see large chunks of ice.
Why is what blurred?
Fall off the rocket that is expected.
Diving back into some more chat questions.
I don't see what's blurred. It's pretty clear.
To achieve the goal of daily spaceflight, or is it possible to get there with expendable vehicles?
Well, as we've talked about, our strategy really focuses on expendable vehicles. We are not pursuing reusability at this time. We believe that we can make a rocket that is much cheaper and more efficient if we focus on expendable vehicles.
Gotcha. Another question here. There is a lot of talk about space's commercial future.
Oh wait, in the thumbnail or in the stream? Because if it's in the stream, YouTube sometimes kicks back the quality, so you would have the middle. It's not blurred for me. For the thumbnail? For the thumbnail or the stream? Because the stream. This sometimes YouTube kicks back the quality. So if you're on mobile, you would click the three dots on the top of the screen, you would go to quality, you'd go to advanced, and you'd go to 180p, and then it should be good. I'll try to fix stuff. Oh, that's on the rocket. Yeah, it might be the camera angle.
We talked a little bit about this yesterday. Don't know how reliable that camera feed will be once the rocket actually lifts off, but assuming it does work, we're going to show those as much as possible because they are really cool views. And back to our kind of ground-based camera views again. This countdown currently in a hold, so we're taking some questions in the meantime while those propellant loading operations catch up so they can resume the countdown. Our next question from chat asking about the Kodiak, Alaska launch site. Looks pretty beautiful out there now, but a question in chat asking, is this launch site still usable in the middle of winter?
Yes, absolutely. Our last launch out of Kodiak was actually in December in the middle of winter. So it is a different picture, a lot snowier, but no less beautiful. Our red team tends to be bundled up in beanies and big coats, but we do.
Yeah, it might be them. Let me check their stream. Yeah, for me it's on 180p. That's probably the best live video they can get. I don't know. Yeah, that camera does look very blurred. This one looks very blurred. Yeah, it looks like it's just this camera. Yeah, probably. Yeah, it looks like this camera. I think it's just the camera.
And ensure the safe operation of everything on the ground. So it's pretty remarkable that it only takes 6 people to set up the entire launch site that you see in front of you today.
And the other half of the launch operations team in Mission Control, can you tell us a little bit about where that Mission Control is situated?
Yes, so our Mission Control, we spent a few minutes ago, spent some time walking through those different roles, but that Mission Control team is right here at our headquarters in Alameda. They're sitting directly behind our broadcast area, if you've seen that. This is in our factory, and in addition to these 8 folks, we have about a dozen engineers who are the responsible engineers for the different systems on the rocket. They're the folks who will be polled during our go, no-go polls throughout our countdown, and they are actually also dispersed throughout our factory office. We have a great setup where they're able to be at their desks with a light to notify folks that they should not be disturbed and are in operations. So we are a very lean team as we control the vehicle and operate it for launch.
I have another question in chat here asking, are there any superstitious rituals done before each of Astra's flight?
Well, I don't know if there's any official rituals, but we certainly have our own little superstitions here. Our launch conductor, Chris Hoffman's mohawk, tends to change color as we enter a launch campaign.
Okay.
There's quite a few folks in here who are wearing their lucky socks.
This angle's blurred. For me, everything is blurred on this. Well, it's not blurred, it's just lower quality for me. Yeah, I don't know. I don't know why it's blurred. Yeah, I have no idea why it's blurred.
Questions here. One question about what this rocket's name is. We're calling it LV0006. We're also calling it Rocket 3.3. You want to explain about that a little bit?
Sure. So Rocket 3.3 is the version number of this rocket, and LV0006 or LV0006 is the serial number of this particular rocket. So that Rocket 3.3 number refers to the precise configuration of this rocket, and that includes the changes that we made from our previous flight in December, which was for Rocket 3.2. But LV0006, LV6 is the name of this vehicle, and we're focused on that serial number because we hope to make many copies of this same vehicle, and we also hope to continue to increment those numbers and someday be at LV 9999 and beyond.
Excellent. Continuing on with the questions, another question about the engines that we're using. We know there's the one type of engine on that first stage, there's 5 of them, and then a different engine on the upper stage. Want to talk about those a little bit more?
Absolutely. Always happy to talk about our engines and our fantastic propulsion team that develops them. We've talked quite a bit about the first stage Delphin engines, but the upper stage engine is Ether. It is a pressure-fed engine, and we have one of those powering the upper stage of LV6. It has 740 pounds of thrust at.
Oh, the center of the rocket. That's ice. The white part? Like the white on the steel?
Another question about what we're looking at on screen here, actually. Is there a flame diverter as part of that launcher underneath the rocket?
Yeah, it's a little difficult to see, but in that sort of cube-shaped structure that the launch stool that the rocket sits on, there is something that kind of looks like a slide. That is the flame diverter for the rocket.
Yeah, we can make it out just in this camera view. You can kind of see it on the bottom there. It'll be nice and obvious at engine ignition. You can see the thrust getting diverted out to the side. So once we reach that milestone, it'll be even more visible. But yeah, you can just make it out in this camera view a little bit.
And we also do have a water deluge system. The deluge test will happen at about T-minus 20 minutes or so as one of the final steps before we enter our terminal count. And that water deluge system serves the purpose of suppressing sound and as well as getting rid of any flames that may fall astray to protect the beautiful landscape and preserve the safety of people and property at our launch site.
Right now, we're continuing on with some questions from chat. In the meantime, if you're just joining us, we are at T-minus 30 minutes and holding. Team's just working to catch up on some propellant loading operations prior to releasing the hold. So we're standing by for a new launch time once that hold can be released. Taking another question from chat, Carolina, someone's asking, what is the next Astra mission?
Well, we are hoping to and on plan to complete 3 missions this year, so you'll have to stay posted on our news for updates about our next mission, but we plan to complete 3 flights this year.
Gotcha, and that'll be more of a monthly launch cadence, which is a part of that ramp up towards the eventual goal of daily launch operations.
That is our hope.
And we have a question about that. Someone asking about what are Astra's kind of thoughts or opinions about the environmental impact of launching these non-reusable rockets, these expendable rockets, at a daily launch cadence?
Absolutely. So we do have most of our rocket is made out of aluminum, which does corrode in salt. So it does degrade. The first stage does degrade when it falls into the ocean. Also, as a smaller vehicle, we are much lighter and can use a lot less fuel. And as we are able to calculate and project where the first stage will land during and after its flight, this not only serves the purpose of helping us to ensure safety, but we are also looking at long-term options to minimize the ocean debris. And similarly, in when it comes to space debris, the materials that we use and the satellites we launch are not intended to remain in orbit forever. And so when the upper stage and theoretically any payloads we launch do fall out of orbit, they will burn on re-entry.
Gotcha. Continuing on with more questions here, we do have one asking about these hoodies. I'm wearing one right now. I don't know if we can cut to it really quick. I can show off the Astra on the shoulder. If there we go, you see. So we do have a question in chat asking, how can we get these hoodies?
Well, we don't have an Astra merch shop at the moment, so the only way to get one of those hoodies is to be an Astra employee or be one of our close friends. So you can learn more about joining the Astra team at astra.com/careers. We have many roles open and are hiring very quickly as we scale up our team and continue to work towards our goals. So if you are interested in working with us and getting cool hoodies, we've got cool water bottles too. So please check out astra.com/careers to learn more about how you can join our team.
And we also have an update to share. We are currently in a T-minus 30-minute hold while they are working on catching up on propellant loading operations. We are hearing that we are getting close to releasing that hold, so we will stand by for a new T0 and provide that as soon as we have it. But stand by for a release of the hold before too long. To kind of finish off that thought about joining the Astra team, we each have one specific question. Does Astra anticipate hiring any DevOps engineers in the near future? Asking for myself, says Alexander.
Well, Alexander, we have so many open roles that I don't know to speak to specific ones, but you can check out our careers page and see the available job postings.
A relevant question asking how many people work at Astra currently?
We are growing so quickly, it is kind of hard for me to keep track, to be honest. But we are, as we've said before, we are still a pretty small and nimble team of a couple hundred folks. So we are growing rapidly, and that number is constantly changing.
And again, as we are getting close to the release of this hold, hopefully, let's go ahead and listen into the countdown net as controllers get ready to resume the count.
Astra LC on countdown will be picking up the count with 30 minutes remaining at the top of the hour.
Yes. Okay. So they're out of the hold. Well, the countdown hasn't resumed yet. You heard the call of their go for resuming the countdown, so it should resume any second now. So let me just get my countdown
And as we
ready.
just heard, again, we're at T-minus 30 minutes and holding, and it sounds like they're going to aim to release this hold at the top of the hour, so 3 o'clock p.m. Pacific time,
so
which translates to a new launch time of just about 3:30,
So 1
3:30
minute.
p.m. Pacific time. Again, we're standing by for the hold to actually be released, but that is our new no earlier than launch time, 3:30 p.m. Pacific time.
So
And so we
they'll
will stand by
release-
for the countdown to
they will-
resume in just under 2 minutes.
yeah, so they'll release the hold in around 20 seconds real time, but the stream is probably delayed by 10 to 15 seconds. So maybe around 45 seconds. Okay, yeah, that's good. They're out of the hold. And I'm getting ready to press to put the countdown on the screen button. So 10 seconds until the countdown will be resumed. 5, 4, 3, 2, 1. Okay, since the stream's delayed, it'll be just a little longer, 5 more seconds. Come on. Please. Come on. How delayed is my stream? There.
This is LC on countdown picking back up. We are currently at step 102. FTS, can you verify that mission data load values are ready to be
Yes.
loaded onto the AFTU?
Yes,
FTS confirms the mission data loads. They're ready.
Please run cast software as required.
okay, so they're going to be...
CAS is running on both AFTUs.
Safety, confirm that you have a head count on all Astra employees and guests in Kodiak.
Safety can confirm. Roll call on all guests. I have 2 at AMC. The rest are with me.
Copy, thank you.
So the next event would be a 20-minute hold. It'll happen
And as you've just seen, we have released the hold. We're at
It will happen at T-minus 20 minutes. It'll hold for maybe 10 minutes or so. So they're targeting a liftoff at 6:30 or 3:30 p.m. Pacific time. For me, it's 6:30 because I'm on the eastern shore. So, yeah, let's put back on stream audio.
Actions to address the issue with yesterday's abort, so everything will hopefully proceed smoothly from here.
As we get closer to the business end of the countdown, we're going to want to turn our attention to the countdown net and the launch proceedings. So we're going to get through a couple more questions here before we get to that point. A question asking about the process for getting the shipping containers out to the pad look like. Is it trucks, planes, boats? What's used to get all that material out to Kodiak?
So we will generally ship everything in standard shipping containers that will be trucked and shipped by boat, but we have also shipped our rocket by air cargo in the past and do have that capability as well.
And on a related note, Astra is known for this mobile launch system. It's a very defining part of the Rocket 3 architecture. What existing infrastructure is needed at Kodiak to host all of those systems?
Yes, so we like to say that all we need is a concrete pad and an internet connection, and that's pretty true. We have the capability to bring pretty much everything else we need to the launch site in order to set up and fly.
Gotcha. And another question about that launch system, asking how does the rocket firing on the stand affect that launcher system, and is there any refurbishment needed between engine firings?
So as we've mentioned before, that everything that you see, we pack up and use to test at our headquarters in Alameda, at other test sites near our headquarters, as well as shipping that up to Kodiak. So we do have a pretty well-established procedure for checking out our systems and making sure that any repairs can be made. But generally, these systems are pretty rugged, and we pack them up and send them on to their next destination. So after the ignition yesterday, our systems continue to be in good shape.
Another question about the launch site, asking what are the two, in parentheses, towers for?
Yeah, so this black tower that you see on the left side of the screen now, and now you see both of them on either side. That's our lightning protection system that prevents the rocket and the launch system from being struck by lightning.
It would not be a NASA spaceflight stream without talking about lightning protection system. We have to hit it every time. It's basically in our contracts. Continuing on with the questions here, is this a cargo-only rocket, or could Astra one day carry a human capsule?
We are focused on sending cargo missions. That is part of how we're able to focus on low-cost vehicles and manufacturing techniques, because we don't need to provide all of the life support systems you need to send people. We're pretty fragile cargo, so we're sticking with satellite payloads.
Gotcha. Again, if you have questions, throw them in the chat. Tag us at NASA Spaceflight. We're coming up on T-minus 25 minutes and counting, and that terminal count starts at 15 minutes. So we've got just under 10 minutes left until we get into the really business end of this countdown, and we're going to want to keep our focus there once we reach there. Right now, you can see the rocket is propellant loaded. You've got the liquid oxygen tank, nice and frosty, in the middle of the rocket. Below that is that bare aluminum for the kerosene tank at ambient temperature. Above that, you can see the inner stage and the payload fairing. Those two together are encompassing the upper stage. And the mass simulator payload, the test payload from the United States Space Force's Space Test Program, which of course will not be deployed from today's launch. But that is the vehicle you're seeing next to the strong back with all of the umbilicals. You can see some venting from the liquid oxygen and the gaseous oxygen venting out of those systems at this beautiful launch site in Kodiak, as we are counting down towards the launch of LV0006. Yesterday we had an abort at T0, and we have a question in chat asking about what happens to that propellant after you have to scrub a launch.
Yes, so yesterday after we scrubbed our launch attempt, we essentially pump the propellants back off the rocket and start fresh today. So the same system that we use to load propellants onto the vehicle is also set up to be able to pump them off in a safe way and not dump them overboard or anything like that.
So everything that we're not seeing, vented from the vehicle, obviously there's some oxygen venting because that's how you keep tanks pressurized at the right levels and things like that. But all of those other commodities just come right back off the rocket and are used again.
Mm-hmm. That's right.
Gotcha.
Okay, so the next event will be in about 4 minutes. It's the pad deluge system test. For launch, the sound is really loud, so they use water to dampen the sound. It's on the launch pad. It squirts out under the rocket engines, which dampens the sound. So they're going to test that by just running a little water through it and at around T-minus 20 minutes. And that's going to happen around 3.5 minutes.
Loading. Loaded.
Igniter is unchanged. 106, Victor 9.
106, Victor 9. Loading. Loaded.
Thank you, Delphin. Ether, can you please provide your config?
Ether is 101, Victor 12.
I have no
Ether
idea what they're
controller
talking about.
101,
So
Victor 12. Loading.
yeah, I have no idea what they're talking about.
Loaded.
I think they're going through go-no-go polls. I hope.
Elder's good.
Guidance, what is our latest guidance config for the vehicle?
We're going to use guidance version 5 Victor 131 L4 balloon.
Copy that. Guidance version 5, Victor 131. Loading. Loaded.
Copy, thank you all. If config is late loaded, Tango in VB1 turn on off PDBs. Please give me a GNC setup. Call out when complete.
Copy that. Setting up.
And what we just heard, they have loaded those software engine configurations into the rocket as we get towards 21 minutes and counting
That's
now.
what it was.
And that was the Tango call sign, which we have a question in chat about. We heard some callouts during the countdown yesterday. Tango is always ready. Is Tango still ready?
It appears that Tango is still ready. And that Tango is our vehicle controller, Steve Lai, and he is loading that software configuration onto the vehicle. We're getting weather data through weather balloons during our countdown procedure, so we always like to have the latest and greatest before we attempt to launch.
I don't want to spoil any future NSF developments, but I must say we have some cool audio bits in that opening sequence, and I think we might have found a new one here at Astra because that's just so cool. Another question from chat here asking about those Apollo engine thrusters, the Apollo Fusion thrusters. Can you talk a little bit about that?
Yeah, so the Apollo Fusion is a company that Astra recently confirmed the acquisition of back in July, and we are very excited to have that technology and team on board. They share a lot of, their approach is very similar to a lot of our philosophy at Astra about rapid design cycles, focusing on ease of manufacturing and assembly. And this past week, Apollo Fusion Thruster did ignite in orbit, which is an amazing accomplishment for that team. And together, we're working on providing rapid and low-cost access to space.
Okay, so in about 10 seconds, they're going to be testing the water deluge system.
It's away from the beginning of the terminal count, so a brief status update if you are just joining us. We are targeting a liftoff time of 3:30 p.m. Pacific time after a hold for some propellant load operations to continue. All systems appear to be operating nominally right now. Carolina, can you just give us a status update of where we're standing now?
Yes, we're just inside T-minus 20 minutes, and as you heard a few moments ago, we have loaded our final
There
software
you can see
configuration.
some shiny stuff under the pad.
The team
I
will
think
now
that's
be
just some
working
water
on spinning
that's
up
running
our
into
first
the
stage
pad,
engine pumps.
and it's like, yeah.
Preparations, including our water system, our water deluge system test, and that will signal
Or no, that's not
that
it.
we have entered the terminal count at T-minus 15 minutes.
And if you're tuning in after yesterday's attempt, we know we did have an abort at just about T0 yesterday due to a engine configuration, and they have applied that corrective issue to come back towards today's launch attempt. We also had a hold during the webcast today of the propellant loading operations just catching up before we released and targeted this new 3:30 p.m. Pacific time launch, and everything proceeding nominally now. This is the test flight for the U.S. Space Force's Space Test Program, a test payload on board today that will not be deployed, but Astra's third orbital launch attempt with LV0006, the debut of the rocket version 3.3. As we come up on 18.5 minutes, we're going to go ahead and listen in as the teams prepare to enter the terminal count at T-minus 15 minutes.
Okay, so the sound suppression system or water deluge test is going to be pretty soon. Hopefully. 15 seconds to enter the terminal count. Yeah.
Confirm status of ESC flags.
Okay, here.
ESC flags are nominal.
Okay,
Tango,
that's
toggle dry spin both.
Dry spinning both.
That's good.
Back to idle. Delphin, please confirm results of pump spins.
Pump spins are nominal.
Yeah, so they're spinning
Copy,
the pumps.
thank you. Tango, deactivate AV1 power ESC ace dry spin.
Machine deactivated.
Delphin, confirm your system is ready for launch.
Delphin is go for launch.
Ether, confirm your system is ready for launch.
Ready for launch.
CDH, please set aux ISO target pressure back to 90 psi.
Set.
Okay,
Tango,
so they're
verify vehicle looks ready for launch aside from tank levels and pressures.
Okay, so the vehicle's ready for launch. So everything looks good.
Good work.
That was the go no go poll. So they were verifying all the systems to make sure it's go for launch, and it looks like it's good. So we're now at 16 and a half minutes away from 16 and a half minutes away from launch.
GNC, confirm
Yeah,
wind
and-
profiles still look acceptable for launch.
Confirmed. Wind profiles look acceptable.
So Tango on countdown. Vehicle looks good.
Copy. Tango on the buttons interface, please toggle spark for 30 seconds.
Copy that.
Okay, so they're toggling the sparks, which
Sparking
ignite
in
the engines.
3, 2, 1. Spark.
Oh, you can see the sparks. But the sparks are what ignite the engine, so they're testing for around 30 seconds.
Spark off.
Delphin, please confirm current on all 5 igniters.
Current draw is nominal.
Okay,
Copy,
good.
thank you. This takes us into our water test. Tango in the water system machine, toggle deluge to on. You will toggle back off on my call.
Copy that. Deluge on now.
Okay, so now they're sending water through the sound suppression system. Oh yeah, you can start seeing some
Off.
there. There's the sound suppression test.
Good. Deluge test. Tango in the water system machine, toggle
looks
pump
cool.
full to false.
False.
Okay.
Team.
Uh-oh. What happened to the rocket?
And you just saw the successful water deluge test as we have entered the terminal count at T-minus 15 minutes and counting. Carolina, let's go over those details for today's mission now that we've entered terminal count.
Sure, Thomas. LV-6 is Astra's 3rd orbital launch attempt and a demonstration mission for the United States Space Force Space Test Program. It's also our first commercial orbital launch, meaning the launch is being conducted under an FAA commercial launch license. Our goal today is to successfully reach orbit with a test payload that will not be released. This orbital demonstration launch allows our team to verify numerous upgrades to our launch system since Rocket 3.2 in December of 2020. Today's launch is an important milestone in our work at Astra and a crucial step towards launching our next payload. You can find more information about the flight at our website, astra.com, and we explain more about our approach to reaching orbit and our other objectives for today's mission. Before we get further into the count, I'd like to give a big thank you to the entire Astra team and their families watching with us today. We really couldn't do this without you and all of your support, so thank you again. As a reminder, back in December, Rocket 3.2 successfully passed the Kármán line, the 100-kilometer altitude that's commonly used as the demarcation of space. We learned that Rocket 3.2 shut down about 12 to 15 seconds too soon after depleting its fuel, only half a kilometer per second short of orbital velocity, which sounds like a lot, but that is so close. And since then, we fine-tuned the mixture ratio between our kerosene fuel and our liquid oxygen to propel us the rest of the way to orbit.
As we get closer to liftoff, let's talk a little bit about the vehicle that you're going to hopefully see lift off in just under 13 minutes. LV-0006 is a 2-stage launch vehicle, each stage running on liquid oxygen and liquid kerosene. The first stage is powered by 5 electric pump-fed Delphin engines. They each produce 6,500 pounds of thrust, and those are made in-house by Astra. The upper stage, also built in-house by Astra, powered by a single pressure-fed engine called Aether.
To increase the payload capacity, our current rocket has several upgrades from our last
It's holding.
Rocket 3.2. In LV-6,
No.
That's not good. No. they're holding at 12.5 minutes.
Looks.
Let's see what happened.
Software configuration changes that were made, and we expect to be picking up the count shortly.
Okay, so that's good.
So we'll listen in on the countdown to hear that update.
Oh, that's good. She said they're only going to be in the hold for just a little bit longer. So, yeah, let me just around there.
This is Astra LC on countdown. We have resumed count. We held briefly to make a
Okay.
minor change to an engine configuration.
Okay, so one
Picking
back
back
up
up
to
in
14.
terminal count at step 137. FTS confirm. Astra FTS is still enabled and nominal.
Okay, so one up to 14 minutes, but now the countdown is
FTS
resumed.
confirms.
So let me
And as you
get
can
ready
see,
to
the
pull up
hold
the
has been
countdown.
released. We're back at 13.5 minutes and counting. Just a little brief hold, but back into the countdown. We are in terminal count for Astra's launch of LV0006. That gives us a new T0 of 3:35 p.m. Pacific time.
3:35.
And prior to the hold, we were talking about some of the changes to this vehicle. So to increase our payload capacity, this vehicle has several upgrades from Rocket 3.2, which we launched in December. In LV6, we've stretched the first stage tank to increase propellant capacity, reduced the mass of the upper stage, added additional sensors to gather more data about flight environments, and consolidated over a dozen individual components on the upper stage into one single assembly. The main propellant load has been completed, and we're continuing to top off oxygen prior to launch. And so, as we've mentioned before, the vehicle is now in terminal count, so we're performing the final checks before we give a go for launch. We've talked a little bit throughout this countdown about the red team, but I also want to take another moment here, if you're just joining us, to recognize them. The rocket is controlled from our headquarters here in Alameda, but we do send a red team of 6 Astra personnel to Kodiak for that launch. And because our rocket and support systems were designed with simplicity in mind, we only need a very small team on site for the launch. It also helps us limit travel, which has been a key consideration during the ongoing COVID-19 pandemic. All 6 members of the red team are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. We are at just under 12 minutes to liftoff, and we'll continue to listen to the countdown net. In a few moments, we expect the launch team to conduct a go, no-go poll to proceed into tank pressurization and launch.
Okay, guys. Today, from Pacific time, I'd only recommend doing this. Is from Pacific time. I'm going to be streaming at around 3 o'clock Eastern time, so around midnight Pacific time. So if you can stay up late, you can watch the CRS-23 mission for Falcon 9. So they're doing go polls now.
Off.
Toggle off and deactivate fuel 4 operate.
Off.
Fuel 3 supply.
Off.
Fuel 1 FE 300 upper fill.
Off.
Fuel 1 FE 200 first.
Off.
AV1 radios.
Off.
AV1 rocket support cart.
Off.
Please confirm the following are still enabled and running. 0 stop purging.
Active.
AV1 manage polling.
Active.
AV1 manage power systems.
Active.
All flight helium machines.
Active.
VB1 first stage power.
Active.
VB1 upper stage power.
Active.
VB1 turn on off PDBs.
Active.
Water system.
Active.
Tango, at this time, I would like you to enable the launch machine.
Active.
Toggle locks topping.
Toggled.
On countdown, team, this takes us to step 144. This is the poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Dolphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
Go.
Tango.
Go.
Safety.
Safety is go.
LD.
LD is go.
LC is go as well. Tango and AV1 manage polling. Set us into ground only mode, please.
Okay, so the rockets
Ground
go
only.
for launch.
And as you have just heard, the poll has been conducted and the Astra team is go for launch.
If you are just joining us, we are currently just under 9 minutes away from liftoff for Launch Vehicle 6, or LV-0006. This rocket is an orbital class vehicle, so if everything goes well, it is fully capable of making it to orbit. However, as a reminder, today's mission is still a test flight for Astra.
Yes, historically, achieving orbit is very difficult, and for this reasons, we are very realistic about our expectations. Today is our 3rd attempt to reach orbit and our first test with a sample payload provided by the Space Force to simulate mass, and again, we will not be deploying this test payload. For the next several minutes, the team is loading the final flight software onto the vehicle and going through our final checklist for launch.
Right now, we're at just about T-minus 8 minutes and counting. As we enter these final minutes of the countdown, we're going to turn our attention to the countdown nets, to the rocket on your screen, and I'm going to hand off commentary to Carolina for Astra's 3rd orbital launch attempt. Carolina, it's all yours.
Thanks, Thomas. The major flight milestones that we will encounter during flight are displayed on the left for you to follow along. At T-minus 3 seconds, the 5 first-stage Delphin engines will ignite, and if the engine data looks good, the hold-down mechanisms will release at T0, and the rocket will begin its trip to space. At T plus 12 seconds, the rocket will begin pitching downrange to fly south over the Pacific Ocean. LV-6 will reach max Q, which is the period of maximum aerodynamic pressure on the vehicle, at T plus 1 minute and 15 seconds. Main engine cutoff, or MECO, is the end of the first stage burn, and that will occur at T plus 2 minutes and 50 seconds. This is followed by fairing separation and stage separation, and at this point, the rocket will be in space. After stage separation, upper stage ignition occurs at T plus 3 minutes and 5 seconds, the beginning of an approximately 5-minute long burn until SECO, or second engine cutoff, at T plus 8 minutes and 20 seconds. And since we're not releasing our payload today, the vehicle's systems will simulate a signal for payload deployment at T plus 8 minutes and 30 seconds. If we make it to orbit, we would consider this flight to be extremely successful. We are just about 6 minutes and 30 seconds to launch, and all of the systems are looking good. So we are waiting now for the range to give us the go-ahead for launch, and we'll continue to listen in to the countdown net.
Please be go for launch.
RCO, LC on countdown.
So we're under 6 minutes.
RCO, LC on countdown.
This is RCO. Range is
RCO.
green. You are authorized to launch.
Copy.
Yes.
Thank you, sir.
Okay, they're go for launch. The range is green, so there's no one or any planes or helicopters or cars. And there's no one in the area of launch, so they're go for launch.
And
weather
we're
looks
at
good.
5 minutes to T0, and as you've just heard, the range has given us the go-ahead. We are green. And I believe we've got a bit of a crowd gathering here at our headquarters, watching on our big screen here in Alameda. We also have many members of the team watching from home. And at T-minus 60 seconds, the vehicle will transition to its internal control. So we're at 4 minutes and 30 seconds from liftoff. And we will continue to listen to the countdown for these final minutes before liftoff.
Come on. So we're 4 minutes away from the third flight of Astra.
RCO, LC on countdown. At this time, please verify the range is recording all telemetry.
This is RCO. Range is recording.
Thank you. Control room, if you require RF data after launch, be prepared to switch over your Grafana pages.
So, just a little over 3 minutes before liftoff. We are coming up on the terminal count.
FSO, be prepared to issue option command at T+164, calling out at event.
FSO copies.
3 minutes. Reminder, control room, any 3-word hold from here on out is an immediate abort, regardless of source.
Okay, so the thing we don't want to hear is hold, 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 because that signals an abort. Oh, they put the telemetry on screen, so they're just a little over 2 minutes from launch.
FTS at this time, please send master enable and watchdog on AFTU.
And work.
Two minutes.
Master enable and watchdog have been issued on both AFTUs. Both AFTUs ready to fly.
Copy, thank you.
Under 2 minutes to go till Astra's launch of LV0006.
Okay, so I'm gonna, at around 1 minute, I'm gonna remove the countdown, and at 30 seconds, I'm gonna full screen the rocket.
$90 seconds. ACE At this time, start PSD recordings.
Both started.
"60 seconds. Vehicle is on internal control." First stage LOX tank is pressing. First stage fuel tank is pressing. Upper stage tanks have gone to liftoff pressures.
Okay, 30 seconds.
30 seconds.
Come on. Okay, so 15.
15.
Okay, 10.
10 seconds. Water
Sounds
system
pushing.
on. 8, 7, 6, 5, 4, 3, 2, 1. Ignition. 0.
First motion.
First motion.
Oh. 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 That's not normal. Is that normal? It's slid.
LB6 is carrying path. It's on its way to space. Our next objective is Max Q.
That was normal? That's slid. That slid so far. That did not look normal. Oh my
Looks like we're getting some
gosh.
really great footage
That
from our onboard
slid
cameras.
like. It's supposed to do that? That did not look normal. Oh my gosh. That scared me. Okay, so they're into the first stage burn.
Rocket has cleared the island.
Okay, so the rocket has cleared the island. Okay, there's past the max Q, maximum aerodynamic pressure. So
Approaching nominal downrange trajectory. Tracking.
And at this point, we should have also passed max Q, which is the period of maximum aerodynamic pressure on the vehicle. This is a
wiggling around
significant
a lot.
milestone and the most physical stress the vehicle will experience during launch. Our next milestone is MECO, or main engine cutoff, which is about 30 seconds away.
Oh yeah, 30 seconds away from Nico. That looks really wobbly. Uh-oh. Ah.
Vehicle is passing through max Q.
That...
Terminate send.
Rest in peace.
Terminate received.
Oh no, they had to terminate it. That's not good.
And as you might have seen, there appears to have been an anomaly with the vehicle in flight. And we will first and foremost ensure that our team and others are safe. We take great safety precautions to ensure that no one was put in danger by an event like this. It does look like we got about 2.5 minutes of flight data, which will be incredibly helpful as we make improvements to our next vehicle on our way to reaching orbit. And any flight where we get some data that we can learn from is a successful one in our mind. Although we did not achieve our primary objective today, our team will work hard to determine what happened here. And as we dig into the flight data, we are optimistic about the future and our next attempt.
Let's go ahead to some quick words from Astra's founder and CEO, Chris Kemp.
Today, after a successful launch and liftoff, Astra's launch vehicle experienced an anomaly in flight. While we regret that we were unable to accomplish all mission objectives for the Space Force, our team captured a tremendous amount of data from the flight. We will work closely with the FAA to complete a mishap investigation. Behind me is LV0007, which will be updated based on what we learned from the flight, so we can begin servicing our backlog of over 50 contracted launches. I want to thank our team here at Astra, our partners at the Pacific Spaceport Complex, and I also want to thank our government customers and partners, the Department of Defense, the United States Space Force, the Defense Innovation Unit, FAA, FCC, the Coast Guard, and the community of Kodiak, Alaska. We look forward to seeing you at our next launch.
For now, that is going to conclude our live coverage of the LV0006 mission. I want to give a big thank you to Astra for allowing us to be very transparent about today's test flight, and just a big thank you for today's partnership and bringing live coverage of the mission. A big thank you to you, Carolina, for joining me as well.
Thanks, Thomas. It's not what we were hoping for today, but thanks for having us, and we hope to be back on the pad again soon.
Absolutely. From all of us in NASA Spaceflight, the well wishes to the Astra team, hoping to see them back on the pad soon. For all of you watching, thank you so much for joining us. Stay tuned for more spaceflight news coverage. Until next time, see you then.
Okay. That's not good at all. Okay, so yeah, unfortunately they lost the mission pretty far into the first stage burn. It looked like it wobbled out of control. Let me just pull up a few replays. So let's get the launch back up on the screen, and then we can do that. Yeah, so look, you can see, so into the first stage burn, maybe 2 minutes 40 seconds in, so we can like fast forward a bit. You can see the plume expands. That's normal, because the higher in the atmosphere they get. Look, it looked a bit wobbly as it went up, and then so this is the mission control sound. They shut off the engine, and then it just started flipping around.
Max Q.
And then they give a terminate
sense.
Yeah, and then they give the call to terminate the vehicle. They switch the launch pad view, but something I bet a lot of people realized. Look, when it first launched, this so we can skip.
Water system on.
So
8,
look,
7.
it goes
6,
here.
5, 4,
so it lights.
3, 2.
So you can see it lights the engines. It ignites, and then it lights, and look, it pitches all the way to the side. I don't think that's normal at all. And then I was surprised it didn't terminate it there, and like you can see that view, it's not coming up, and then it's all the way on the side, and it's moving a lot. It's moving horizontally a lot. And then if we just skip forward up into about 2 minutes into the launch, you can see there's probably an issue, so they shut down the engines. So you can see they're shut down, and then it starts flipping around. You can see there's stuff falling off. It starts flying around, and then they give the call to terminate it. So it cleared the island, so there's probably debris falling around in the ocean. Yeah, but that's not good. I'm just gonna replay the launch again because that's slid off course. Yeah, that wasn't the best outcome. Yeah, unfortunately, they did lose it, but hopefully they're back on the pad really soon. Yeah, look, it rolls and then just slides off the pad. I'm not sure if something hit the pad or like an engine might have hit the pad, but That view you can see it starts rising. You can see the ice, it's falling off, but that's like falling really horizontally. Then it cancels out its horizontal velocity pretty well once it gets into the flight, but that doesn't seem good because it doesn't seem like the best way to burn propellant. Like, just look at this. Wait, let's play that in slow motion, so playback speed. So we can watch that in slow motion. You can see the sound suppression, it ignites. You can see some flashing under the base. So they call out first motion. Oh look, there was no plume. So look, the plume stopped, and look, it veers horizontally pretty fast. And it just slides sideways, sort of like SN5 and SN6. But I don't think it's supposed to do that. I think it's supposed to go more vertical. And then they cut to the other shots soon. Let's watch the explosion in slow motion. We can't see the explosion, but we can see it like fall apart. So it's up around here. You can see the plume is expanded, and then they probably had an issue, so they shut down the engines. And then it started flipping around. Maybe one engine didn't light and they just kept flying. Maybe. But like, look, you can see that piece falling off. You can see it's like, once it does that, it can't be recovered. Yeah. Then it just starts flipping, and then they give the call to terminate it. That's not good at all. And then after that, they just cut back to the launch pad. But look, we can watch that liftoff again. Let's watch it in real time first. So let's go to maybe around 10 seconds. Let's go to normal speed. Look, you can see. And then you can see they light the engines. And then they launch. It rolls, pitches off, probably hits something on the launch pad because it looks like there's a bunch of debris flying around. And then it exploded a while later. So that's not what I hoped to see today, but unfortunately that is what happened. So yeah, unfortunately that's what we're gonna have to end with. So thanks guys, make sure to like, subscribe, and yeah, please don't make fun of them. They try really hard, and we'll see you guys next time. Josh Shup commented, I'm sorry if I pronounced your name wrong. Looks like one of the hold down clamps released too late. Yeah, it does look like that. So, yeah.